Hi, welcome back to another session of learning Rust with Rust tutorials. In this session, I'm going to just go backwards a step. I showed in my first video how to install Rust on a Linux machine. In this tutorial, I'm going to cover the same steps, but this time I've got a Windows machine. It's a brand new Windows machine. I'm going to install Rust on there, and then what I'm going to do is I'm going to recap some of the things I've covered so far in other tutorials. Once it's installed, it should be pretty much the same, but it just saves you having to go and hunt for other tutorials. So I'm going to cover doing an installation, then I'm going to do a Hello World project, then I'm going to do a similar Hello World project involving cargo and installing some dependencies, and then finally I'm going to cover what I've covered before in my third one, which is some simple functions. So let's get started and go into the first tutorial. So here I am in a Windows machine, and first of all I've gone to rustlang.org. I'll put the link in the description, but I'll also, it's probably just going to flash up on the screen, or you can see it here. And I'm going to click Get Started. Okay, so just here in the Getting Started, this has automatically come up because I'm on a Windows machine with the Windows information. I'm going to download this install file here. I'm going to click Open the file. Just one thing to note, I do have administrator privileges on this machine. I did try this a bit earlier and it did require me to have some admin privileges. So if you need to go and get admin privileges, talk to your system administrator or whatever, or give yourself admin. So I'm just going to go with this quick install, and see what happens. So it looks like I'm going to need Visual Studio Installer. So I'm going to just click Continue. So it's just saying we'll install the frameworks, SDKs, and the tools you'll need. You can add more later using the Visual Studio Installer. So it's just giving me a couple of individual components. So I'm just going to click Install. Okay, so that took way longer than I was expecting. First of all, I had to download Visual Studio Code, and I had to install Visual Studio Code. I'm going to include that section because I think it's important if you've never done it before, and so you can see the progress. But I'm going to fast forward through that sequence, as you probably noticed, and I'm going to post the time it took my machine to take. You may have a different connection speed, you may have a more powerful computer, so it may take longer or slower depending on your machine. So after that, I followed the prompts to continue to install Rust. I'm going to go into a Visual Studio Code now, and I'm going to see if Rust is installed properly. And I'm going to open a terminal session, and let's see now if Rust is installed. Okay, so Rust is installed, which is great. That's kind of exactly what we wanted. So the next thing that we can do is we can check to see if there is any Rust updates. There won't be because we've just installed it, but we can do Rust up, and then we can do update. And we can see that it's the same version, so there's really nothing to show there. I'm going to just add a new folder in here. I'm going to call it Rust, And then inside Rust, I'm just going to create a new file, and I'm going to call that main.rs. Okay, so if I've got that file open, then I should be able to do fn main, some brackets for the parameters, and then print ln exclamation for a macro, and then hello world. Okay, so I've just given this a simple hello world main function, and I'm just going to go into my terminal here. So having created the main.rs file with the hello world function in, the next thing to do is to compile and run that function. So I'm going to do that now. Okay, so having written the hello world function, the next thing I need to do is to compile and run it. So to do that, I'm going to do rustc main.rs, and you can see over here the compiler's run, and it's created a main.exe and this other main.pdb in addition to main.rs. So now in order to run this executable, the next thing I'm going to do is call it from its path. So I'm going to do main.exe, which returns hello world, which is kind of what we were expecting. So we've managed to install Rust, we've managed to do a hello world program now. So the next thing I'm going to do is I'm going to get rid of this, I'm going to strip everything out, and I'm going to install it using cargo instead. So let's get rid of our files here. So we're now pretty much back to scratch. Let's just get rid of that main. Okay, so that's gone now. So I'm now back inside my Rust directory, and instead I'm going to use cargo to create my hello world program and a whole load of other scaffolding that we can use. So instead of using just the kind of create directory, create main.rs, I'm going to do cargo new, and I'm going to call it hello world. I have covered this in a separate tutorial, but cargo is the package manager that comes embedded inside Rust. You're going to be using cargo a lot for most of your commands rather than the way I've shown you so far. So let's just take a look at what's been created. So if we go up here, we've got a source directory. And inside we've got a main.rs file, which has pretty much reproduced exactly what I had before. So now with cargo, I can just do cargo run. First of all, I'm going to have to change into that directory. Change into hello world, and then if I do cargo run, it's going to compile and it's going to run my code, and I get hello world. So just going through a few other things, we've got our main.rs file in here. We've got git ignore. We can literally ignore that for now. It's not relevant to what we're doing, but it's used by the Git repository tool. Inside target, we've got a debug now that we've compiled the code, and inside here you can see that we've got another hello world exe here. So if I was to copy that path and paste it into here, I should get the same outcome. So I do, I get hello world. So our target is in here. this cargo toml file. It gives us some information about our package, the version and the edition, and we can have some dependencies in here. I cover dependencies in a separate tutorial, but this is going to be where we add packages that have been written by other Rust developers that we would use as dependencies to our program. So it saves you coding everything from scratch. You use open source dependencies and packages, and you bring those into your code. And we're going to be doing those in later tutorials when we get round to interacting with AWS services. So we can ignore that for now. The only other thing I wanted to cover, if I clear my console here, is there's a difference between when you compile your code using the development release and also a release. So having done cargo builds just with no additional flags on it, what it's done is produce an unoptimized version of the code. You can see that if I do cargo build again, you can see that it's finished, and it says that the code is unoptimized, and it did that in 0.03 seconds. So what I'm just going to do now is I'm going to show you that you can release your code when you want to kind of actually, release your code into production or whatever. You give it a separate flag using cargo, and it will optimize the code for you. Now this should do this quite quickly because effectively it's a hello world example. There's no additional dependencies, but the difference is that a release version will take longer to compile, and in taking longer to compile, you have trade-offs. So when you're developing, you want to just use the ordinary build release unoptimized because it's going to be fast to compile, which allows you to iterate faster. When you do a release, it's going to take longer to compile, but it will be faster to execute. So I'll show you how to do a cargo build, and then we do release. So this would be if I wanted to build for releasing my code into production. Okay, so it didn't take long because at the end of the day, it's only compiling hello world with no dependencies. But you can see that instead it says that the profile is optimized, and you can see that it did take a little bit longer to actually compile that code. In fact, in computing terms, it took quite a reasonable time longer considering it's the same code. So just the trade-offs again, like if you're iterating fast and developing, you just want to build an unoptimized version of your code. And then when you want to release for production, you want to use that release flag. It will take longer to compile your code, but then the code will run quicker. Okay, so having got a hello world example running, the next thing I want to cover is creating a function. Functions help us break our code down into discrete building blocks. So we take a large problem, we break it down, and we put the logic into individual functions. Functions have a few characteristics. They should have a name that is easy to identify the purpose of the function. Typically, we want to try and make sure that we only have a function doing one task. If the logic gets too complicated and we're trying to complete multiple things, it's best to break them out into different functions. So this is a process called decomposition. So for now, I'm just going to create a simple function. It's just going to add two numbers together, and we're going to call it from the main function, which is the entry point into our code. So back in the terminal here, I'm just going to go up above. The main function is the entry point into the code for an executable. As I said, it doesn't really matter whether the main function is at the top or wherever it is in here, but it's probably best to put it at the top or the bottom by convention, not buried somewhere in the middle. Okay, so I'm going to create a new function now. So add numbers. I'm going to create two parameters in here, A, and I'm going to give that a type of i32, and B, and I'm going to give that a type of i32 as well. And then I'm going to return from here a value of I32 as well. So this is going to be a very simple function. You can see what it's going to do. So first of all, we need to have a variable to hold our result. So let's call it result. And it's going to just be A plus B. And then we want to return result. Okay, so we've created our function, given it a meaningful title. It takes a parameter of A and B, both of those are I32, and it's going to return a value of I32, which is what we would expect. We then have a variable declared, let result equal A plus B, and we return result. Okay, so down in this main function here, I'm going to delete this, and from the main function I now need to call my add numbers function with the parameters. So first of all, I'm going to declare another couple of variables. I'm going to declare number1 equals, let's say 10. Let number2 equal 20. And then from here we need to create another variable. Let sum equal, and we need to call our function add numbers, and then we provide num1 and num2. Okay, so after that, what we want to do is we want to print out the result. I'm just using brackets to indicate placeholders. And then we provide where the variables are going to be in those placeholders. So we want to have num1, num2, and we want to then have sum. Put in some space. Okay, remember to save my file and then do cargo run. Great, so that compiled okay, and we can see the result down here. The sum of 10 and 20 is 30. Okay, so the next thing I'm going to do now is I'm going to optimize this, because we can do this in a slightly better way. First of all, up here, we're returning result. You can see that the result doesn't have a semicolon at the end. So this is returned to, it's returning the result implicitly back to the function that called it. So I'm going to get rid of that, and I'm going to, instead of using a variable, I'm going to get rid of that. Remove the semicolon and indent here. So by removing the semicolon at the end now, what I've actually done is I'm going to return just A plus B directly to the function that called it. And you can see that it's removed quite a lot of extra wording out of here and made up my code clearer to read. So I'm going to remember to save my file, and I'm expecting the same result. It's just in a neater way of doing it. Okay, so I get the same result. So basically what we've covered now is we've just covered how to write a main function and call the add numbers function. We then covered how to make and simplify that function by removing some of the additional words that we don't need. Okay, so I hope you're able to follow along there. In some places, my remote workstation was a bit slow, which didn't help, but got there in the end. I hope you found that session useful. I have covered this in additional topics and in some areas in slightly more depth. If you are using a Windows station, this should now be kind of pretty much the same on Windows as it is on Linux. So I'm going to do the rest of my tutorials on Linux rather than Windows, but now you should be able to see how to install on Windows, create Hello World, use Cargo to create Hello World, and then also just start with some basic functions. Hope that's been really useful, and please subscribe to the channel, give this a like if you like what I'm trying to do with these tutorials, if you want me to do more. Be really interested to get your feedback in the comments as to what your experience was like installing on Windows. Okay, so thank you very much.